Last time on the Race to Superintelligence.
Actress Scarlett Johansson is accusing the parent company of OpenAI of using a likeness of her voice without her permission.
Not only did she refuse a request from OpenAI to voice its new virtual assistant, she declined after the company's CEO approached her twice. Now she says the company reluctantly agreed to take the voice they called Sky down only after she hired legal counsel.
AI systems that generate words, art, and human-like voices require an incredible number of examples to learn those skills, most of them taken directly from the internet without consent. And it turns out, even the highest-paid woman in Hollywood might not be exempt from this.
In a statement, Johansson said the entire situation left her shocked, angered, and in disbelief.
Geoffrey Hinton's resignation from Google, followed by a letter asking for a pause on the most advanced AI research, signed by people like Bill Gates and Elon Musk, all of it grabbed the world's attention. But for many working in the field, it was seen as a distraction from issues impacting lives right now. This is part 3.
Artificial intelligence, a machine beyond the mind of man. It's science fiction, but is it also fact?
What do you think artificial intelligence is?
My favorite definition of artificial intelligence is just computers doing smart stuff.
If that sounds very broad, that's because it is. Intelligence is a squishy term.
If the human brain can solve all kinds of different tasks, can we build programs that can do the same thing?
There's no real reason to believe that humans are some sort of peak of intelligence.
How do you define what the brain does?
This is the Race to Superintelligence. I'm Jennifer Strong.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in 2 US cities.
I would say that one of my greatest skills is my ability to interact with humans.
Elon Musk says his AI startup xAI will need a huge number of computer chips to train and run the next generation of its chatbot, called Grok. He told investors he plans to combine 100,000 of them into just one massive computer. This would be maybe 4 times the size of what his competitors have now. And it will be so expensive, it could burn through the $6 billion he just raised, even before it comes online. It will also consume unbelievable amounts of power, which is already a big problem for the industry.
Just tracking how large these models were getting, I felt like the best way to really drive home the physical costs of this technology was to go to the data center, because that is where the impact is happening, and also that is where the physicality really manifests. Hi, my name is Karen Howe, and I am a reporter covering artificial intelligence.
She's a contributing writer at The Atlantic, where she wrote the story, AI is Taking Water from the Desert.
The energy story is a little more obvious, the emission story is a little bit more obvious, but the water story is really not an obvious one. I did not think that something like ChatGPT consumes a lot of drinking water. And I was really surprised to discover a massive cluster of data centers in Phoenix, Arizona. And they consume a lot of water in a place that is currently suffering the worst drought in over a millennia.
Data centers take up massive tracts of land. We're not talking football fields either. Think more like the size of a college campus. And for technical reasons, she says these data centers are often cooled with water.
They're tapping into the drinking water source of various cities that are oftentimes under severe drought. And so there's just all of these really complicated costs that come into the development of these technologies that are largely invisible, because we think of AI or the cloud or these concepts as these very pristine digital entities that just float somewhere in the sky. And it's absolutely not that way. They're very much grounded in the real world and have costs in the real world.
Those costs also include the mining of natural resources.
You can't talk about AI if you don't talk about how you make the machines that create AI systems. My name is Kambale Musavoli. I am from the Democratic Republic of Congo. I am an analyst with the Center for Research on the Congo-Kinshasa and also the founder of Ether Strategy. You can't have a Tesla without Congo's cobalt, right? And you can even have a drone without Congo's cobalt. Congo is the #1 producer in the world of cobalt. And cobalt is considered a critical mineral. Both the United States and EU have policies that they are putting in place for access to these minerals, and they're not taking into account how children are being put into the mines, digging in with their bare hands. The people who own those resources are not benefiting from it, and nothing is being done to protect them. And when you divide the analysis of AI ethics away from also the human labor that creates that wealth, then you'll never solve the problem.
Part of the problem here is we tend to think of technology as something abstract. In reality, like our own intelligence, AI is physical, and that's why we can't divorce it from the things that power it, the exploitation of the environment and of workers, including children. We're still thinking about how to responsibly build and use these technologies. We only figured out that cars need seatbelts after we started driving, and that's going to happen here too, in this race to build automated systems. In some cases, these systems are supposed to be able to make decisions faster and more fairly by removing our own errors and biases from the process. And we've quickly come to rely on these tools to automate some pretty sensitive decisions around things like credit, jobs, and policing.
Whether you're using a simple Excel formula or using a cutting-edge form of machine learning, if you're using technology as a substitute for human decision-making and human discretion, we need to have safeguards that come into effect. My name's Albert Foxconn. I'm the Executive Director of the Surveillance Technology Oversight Project.
We're sitting outside New York University's School of Law, where he's also a fellow.
NYU kind of captures so much of what's going on in AI at the moment. We have researchers who are getting paid extraordinary amounts of money to develop really problematic AI tools. We have scientists who are studying how you audit and evaluate AI, and you have a lot of lawyers like me trying to figure out, well, how do you sue the bastards, and how do you actually create legal governance strategies that can make the people who are profiting off of harmful AI accountable for the impact they're having.
And sue he does. Foxconn is well known for his lawsuits around the use of facial recognition and other surveillance technologies. He acknowledges that we humans are flawed too, but we have strategies to hold human beings accountable, and we don't really yet for this technology.
If I were still a corporate lawyer, if I was still advising large companies, I'd say take your riskiest decisions, the ones that you think are most likely to get you sued, and have an algorithm do them. Because it is going to be so much harder for someone to sue you for using an algorithm to make the exact same decision than it is for a human being to do it. Because oftentimes there's no way to get your foot in the courthouse door when you've been harmed by an algorithm and not a human.
He's been fighting the use of facial recognition here in New York City for years. In fact, he founded his organization, at least in part, to try to get it banned.
We asked the NYPD back in 2020 for records of how biased and accurate their facial recognition system was. And they told us under oath that they have no data on the accuracy or bias of their facial recognition system, which would be kind of shocking if it were true. But in fact, we found out it was not true. And now, 4 years later, we're still litigating, trying to get access to the basic records to document how this technology is failing and who is being harmed.
He says these are the sorts of records that would be incredibly easy for lawyers to get access to if it were a human decision maker. Meanwhile,
as we're sitting here, I looked up, and do you see what I see?
Oh, yeah. So we are being viewed right now by one of the more than 30,000 cameras that NYPD has deployed around New York City, the sort of ubiquitous panopticon that defines city life. And so increasingly we live in a city where almost every moment of our day is being photographed. And that was kind of creepy in an analog era, but in the age of algorithmic surveillance, where you can use facial recognition, object recognition, and other forms of tracking, you can potentially create the infrastructure so that as we walk around the city from camera to camera, AI can track our faces, identify us, and reconstruct our movements.
And he's working on legislation that would try to tackle these issues differently.
So right now there's a catch-22 that when you have been harmed by AI, oftentimes you need the sort of information about the model that harmed you that you can only get through discovery in order to bring a lawsuit. But you can't get that discovery until you've brought the suit. So it's this constant chicken or egg problem. How do you bring a lawsuit to get the information that you need to file that lawsuit in the first place?
So he's working on a way to flip the script and looking to Europe as an example.
We say, hey, you chose to use AI, so now you bear the burden of showing that the plaintiff wasn't harmed and that your AI was operating lawfully. And if you can do that, great, the case is tossed out. And if you can't, now we have an opportunity to actually go into discovery about the model, to actually understand how it was operating, and to begin to, have an adversarial process that looks at whether or not this is something that's fit for purpose.
Others are looking a bit closer to home.
We hear a lot of concerns about technology replacing human jobs. It's not just jobs, it's dignity, it's meaning of life.
That's AI pioneer Fei-Fei Li, founder of Stanford's Institute for HumanCentered AI.
It dawned on me that we are entering a new phase in this whole civilizational journey, and technology will play a profound role in our lives, and yet we don't talk about humans in artificial intelligence. The very name is artificial. And I began to share with my students there's nothing artificial about artificial intelligence. It is created by people. It is used to develop applications for people. And eventually it has to be governed by people.
Her work in the past led to rapid advancements in computer vision, shaping the field and making it what it is today. It's how computers get meaningful information out of things like photos and videos. These days, she's focused on understanding how AI can improve the human condition, and her team at Stanford brings together different disciplines and sectors to try to shape the future of this tech and its impact on society.
I'm a scientist, and for me, the race is curiosity. That race is to discover and use that discovery for good. And I think in today's AI, we kind of forget about that race. What worries me is so many people feel they don't even have permission to understand what this is. And then they were promised things like you'll have infinite time and infinite productivity and infinite everything. It just feels not authentic when we communicate AI that way. And then you get to hear there's existential crisis. I think we need to have much more nuanced and responsible conversations. AI is a tool. Every tool is a double-edged sword. It will create social disturbance as any new tools are introduced in our society, whether it's disinformation for democracy or job displacement or fairness and privacy issues. We need to face them.
And her own experience going through the healthcare system with her parents has led her to really think about how the relationship between people and AI could be so much better.
Yes, I'm a computer scientist. Yes, I'm a professor. Yes, I'm an AI pioneer. But in the real life, we have loved ones. I'm an immigrant, and especially as the only English speaker and the only child for my ailing parents, I spend a lot of time in every imaginable healthcare scenarios. If we don't have human-centered AI, we will be developing technology that's devoid of the human consideration. And I see this so deeply in healthcare, right? We use a lot of technology in healthcare, but there's nothing we can do. No matter how good the drug is or the medical device is, to touch human dignity, self-respect, the vulnerability. That has to come from humans themselves, as well as the kind of human compassion for each other. And these are things that if technologies are not human-centered, we will lose that. And that is not acceptable for our civilization.
We're in a global race to build and develop superintelligent AI systems. And there's still a lot we don't know about where we're racing to or at what cost. But there's also the potential for real benefits, including for things like our understanding of the human body. Researchers are trying to apply their work getting computers to play complicated games to helping us better understand and fight disease. And if you stop and think about it, it kind of makes sense. In both scenarios, there's an adversary and countless scenarios to go through.
We developed a system called AlphaGo, which was the first program to be able to play the game of Go at the level of top human professional players. And in fact, it was able to beat the world champion, Lisa Doll. My name's David Silver. I work on artificial intelligence and I apply it to games.
He works for DeepMind, a London-based research lab bought by Google, where he's been the lead researcher behind some of the best-known AI systems that have mastered how to play games, including that one he just mentioned, the ancient Chinese strategy game of Go.
If the human brain can solve all kinds of different tasks, can we build programs that can do the same thing? There's this huge space of games, many of which have these beautiful characteristics that allow us to really just dive in and understand, one piece of the world in isolation without having to deal with all of the immense complexity of the real world all at once.
That's what Silver's next system, AlphaZero, was meant to do. It learned to play board games and video games in a different way, by learning the rules of a game and then playing itself over and over again.
After AlphaGo, we tried to take the next step and make something even more general, which was able to play not just one game, but many games using the same technology. And this is a big stepping stone because it really is trying to do one of the things which we as people are able to do, which is solve many problems using the same kind of machinery inside.
His next project was called MuZero. This system figures out how to play without being given any rules at all.
So it was really just let loose. It was able to play games against itself. And all it got at the end of the game was a signal to say, hey, you won, or hey, you lost. And from that signal, it was able to build an understanding for itself of the rules of the game, enough that it could actually sort of imagine what would happen into the future. And once it had this ability to imagine into the future, it was able to search and start looking ahead and start thinking into the future and saying, aha, now I understand how this world works. I can start to imagine what would happen if I played this move or took this action. And so that's really a key step that we need and something we believe is very important going forward for the future of AI.
And the work has helped enable some other more practical applications in the real world. That's where human diseases come in.
So one of the problems we've been working on is something called AlphaFold. This is a problem of immense importance to society. The goal is to actually take a protein, for example, the ones found all over the human body, and ask, what shape will this protein make in nature? And if you can predict what shape it will make, then it tells you something profound about that protein. It tells you what it will do.
4 years ago, this AI software helped scientists crack a puzzle that had been frustrating them for 50 years, called the protein folding problem. AlphaFold eventually let them be able to predict the shape of almost every protein known to science.
So if you know the shape of it, you know the function of it.
And if you're dealing with a misshapen protein, which is what happens in diseases like Parkinson's and Alzheimer's, then you might have a better chance at figuring out how to treat diseases that are currently difficult or impossible to treat. And researchers are continuing to try to find other ways to make games a test for real life, because games have rules that can be defined, and no one really knows the rules by which the world works.
The world is really a messy place. It's got this incredibly rich dynamics going on, all kinds of details in the way that objects move around, the way that the things we see relate to the things that we touch. There's just this incredible richness and complexity to the real world. And we can't possibly hope to address that in the way that people historically have approached games. So what we need is something which can understand the world for itself in a way that kind of understands the patterns in a way which is useful for it to make decisions that are actually meaningful in helping to achieve its goals.
He says it's not unlike an infant coming to grips with the world around it, building problem-solving and creative skills over time.
I think we're already seeing examples where within constrained domains that we see algorithms that are, to all intents and purposes, creative. I mean, what is creativity after all, other than, the ability to discover some new idea for itself? And I think that's the essence of creativity. The essence of creativity is what our algorithms are doing, which is to discover step by step something new and to learn through their experience that this new idea that they've come up with is actually something which is powerful and which helps it to achieve its goals. So I think in the future, we'll see more and more creativity of this form. We'll see machines which are able to discover for themselves ideas that help them to achieve goals, not because a person's told them this is the thing you need to achieve that goal, but because they've figured it out for themselves.
That creativity, it led AlphaZero to discover new things about how to play chess. And just like machines learn from us, we learn from them too. Human players now use these moves in their own games, calling it playing an AlphaZero move.
Hi guys, welcome to another episode of Attack Like AlphaZero. I hope you are ready for today's lesson.
The Race to Superintelligence is created and produced by me, with Emma Silikans, Daniela Hernandez, and Meg Marco, with additional research and production assistance from Sonia Gerwit, Neve McAuliffe, Anthony Green, and Luke Robert Mason. The show is mixed by Garrett Lang with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong.
Support for the Race for Superintelligence comes from the Pulitzer Center's AI Accountability Network, supporting and bringing together journalists reporting on AI and with AI globally.